Hi, my name's Simon Dawson. I'm a member of the Salisbury Road and Mountain Bike Club. And what this recorded video is about tyre size and exploring some new ideas, new research into how bigger tyres with lower pressure, can in fact be faster. It sounds counterintuitive that bigger, fatter tyres are faster than smaller tyres at high pressure, but that's what the research is saying. I know that in the club, talking to people, some people have worked it all out, they know what to do, and they've made the transition. Others are less quite sure and are sticking with perhaps what they're used to in their uncertainty. So what I thought I'd do is do a video with what I've learned myself doing some research on this idea, on these thoughts. By background, I'm an engineer. I used to work professionally in sports equipment design, in kayaking more than cycling. But even so, I've got some experience there. Spent lots of time researching on YouTube and on Google for my own learning about what is best for my cycling. And so perhaps if I can pass some of my thoughts on, people will find that helpful and can work towards some better gear for them over the months and years as they can afford to replace their gear, if they want to. So this talk will be in three parts. Firstly, the theory. How can it be that bigger tyres at lower pressure are faster and lower rolling resistance? And also the other advantages they have apart from just speed and energy saving. Then a quick resume about what I think might be the best tyres for cycling around Salisbury for club members. And then thirdly, a talk about how to match wider tyres to the other parts of the bike, the frame, but more especially how to match wider tyres to the wheels that the tyres are mounted on. So let's make a start, and if you'll excuse me, I'll set up a share screen on the Zoom system I'm using to show some pictures. So on a perfectly flat surface, and I emphasize that, on a perfectly flat surface, then smaller tyres at higher pressure have the advantage. They are more aerodynamic and they are lighter, but they have lower contact area with the tarmac. Bigger diameter tyres at lower pressure, less aero, heavier, a bit more friction. And so that's why in the olden days, they thought that smaller tyres were better. They did all of their research and testing in the laboratory on great big rolling drums made of stainless steel, which were perfectly smooth. And in those days, the only advantage to bigger diameter, lower pressure tyres was that you had more of the rubber in the contact with the ground. And so if you're braking or cornering or whatever, it was safer to have bigger grip. If you wanted to go fast, you had small 23mm tyres pumped up massively high. The problem with that is that we never ever cycle on perfectly smooth stainless steel surfaces. We actually cycle on real roads, on tarmac, and tarmac is a bit bumpy. Even the smooth tarmac is slightly uneven, lots of micro bumps, but even if you hit micro bumps 20 or 30 times a second, it has an effect. So you need to look at what happens to a tyre when it hits a bump. This is massively exaggerated for teaching purposes, but even so, the theory stays the same for small micro bumps on rough tarmac. A small diameter tyre, high pressure, rides up over the bump. The tyre, the wheel, the bike, and the bike rider are lifted up slightly to go over the bump. The force to lift everything slows the bike down, lifts it up, energy is lost. And incidentally, by being lifted up, that small contact area with the ground is made even smaller. But what about a larger diameter tyre running at a lower pressure? The tyre deforms, it flows around that bump. And that can take less energy. and therefore less rolling resistance. And the bike is not lifted up so much, just keeps going forward without that lifting, vibrating effect. Interestingly, when you go past the bump, then the energy which is used to compress the air in the tyre can push back on the bump and actually push the bike forward, so you actually can regain some of the energy you lost going up to the bump. Also, because you're not lifted up so much, the contact area with the ground is maintained. You get a lot better grip. So think about that. Because a tyre with a lower pressure allowed by bigger diameter can flow around the bump, then you get less rolling resistance because it's not being lifted up over the bump. With less rolling resistance, you can go faster for less energy. And that's why they say that a bigger tyre with a lower pressure can be faster and better than smaller tyres on real tarmac. Of course, you can't go too far down the size way. Eventually, if you go too far in bigger tyres, you get more friction, you get more weight, more aerodynamic drag. So you lose the advantages. So there's a sweet spot in the middle. And the key thing to understand is that that sweet spot varies with how bumpy your road surface is. Perfectly smooth tarmac, like a Tour de France time trial route, relayed by the council 2 weeks back to get good publicity for their town, massively smooth, and therefore 25 mil high pressure works perfectly on the smooth conditions, or in a indoor cycling track in the Olympics. Small tyres, high pressure. But for us normal people on normal tarmac, which is bumpier, you need to go a bit bigger, a bit lower pressure. And all the research I've said is that for normal bike riders, club riders who want to go fast, on normal roads, the sweet spot is 28 mil at about 70 to 80 psi. But obviously, if you go bigger still onto gravel riding, rougher still, you get bigger tyres, lower pressure. Most gravel riders go at 32 to 40 mil tyres at 30 to 40 psi. Then mountain bikers go on 50 mil plus at 20 to 30 psi. That's the key understanding. You match your tyre to the bumpiness or smoothness of the ground you're riding on. And for most normal tarmac out in the streets in real life, yeah, everybody's saying 28 is about the sweet spot. You can go up or down. If you know that you're going to be going on really smooth roads and being aero and fast is important for you, then sure, go smaller, 25, 23, high pressure, perfect. But alternatively, if you want to say, well, actually Wiltshire, back end of Wessex is rougher and graveler, more gravelly than your average tarmac, I want to go the other way. I'm going to go for 30 mil tyres at 60 psi, because that's what tarmac and Wiltshire is like. That's perfectly sensible. That's what I do personally for my own riding. And I know that a 30 mil tyre at 60 psi has the same rolling resistance as a 25 mil tyre at about 90 psi on real tarmac. And for my winter road bike, it's 32 at 50 psi. It's very little drop in rolling resistance, but much more comfort, and importantly, much more grip. Those are the choices you can make, trying to work out what's the optimum for what I want, balancing grip, rolling resistance, speed, and weight to match the sort of road that you'll be riding on. Is it smooth? Is it bumpy? Is it in the middle? Do I want massive grip? Do I want massive speed? If I'm going for smoothness and speed, sure, 25 might work, but on normal tarmac, 28 will work. If I want to go beyond that for normal tarmac, but a bit more comfort, a bit more grip, you won't get much loss by going for 30 or even 32. That's purely talking about rolling resistance. But there are other advantages too to thinking about going for lower pressure on bigger tyres for a road cyclist. Not a gravel cyclist, but a road cyclist. Firstly, if the little bump on the road you hit is not a little bit of what they use to build the road, but it's a flint or a bit of broken glass from a bottle, then if you've got massively high pressure in your tyres, then there'll be a lot of force pushing the rubber against that bit of glass or flint. But if there's lower pressure and the tyre flows around the bit of flint, then there's more chance of the flint not puncturing. And so that's why they say that lower pressure, bigger tyres have less risk of puncture. The second thing, we discussed it already, lower pressure, bigger tyres have more rubber in contact with the ground, and therefore better control on gravel, better control going around corners or braking. And that can be quite important. It's certainly important to me. The sorts of cycling I do is the back end of Wiltshire, the sorts of road that has grass going down the middle. You go around a corner, you see a tractor coming towards you. I want maximum grip, and therefore I use 30mm tyres at quite a low pressure for that very reason. There's a third advantage, which is lower pressure gives you good suspension. It used to be thought, under the old thinking, that stiff bikes were important to get maximum power transfer from the pedals through to the wheels. The bike wasn't stiff, you'd lose power. And a stiff bike didn't have any give whatsoever. And so you got onto a bike, you got on the road buzz as you went fast, the bike vibrated, and this thing came up that a stiff bike vibrated, gave you road buzz. A bike that gave you road buzz was a fast bike. The problem is with that buzz, that to make the bike vibrate takes energy, and the energy is wasted energy because it's not propelling you forward. But if your body is vibrating as well, that also is wasted energy. You've got to grip onto the handlebars tightly. The muscles or the energy contracting your muscles is not being used to push you forward. And if your muscles or your blood vessels, your heart, your lungs, your kidneys, your liver is vibrating massively, it won't work as efficiently, so your physiology is affected. I read somewhere that on things like the Paris-Roubaix, with massive vibration, riders are using about 50 watts more energy simply because of the vibration of the bike. And if you can get rid of that vibration, that's 50 watts available to go into the pedals. And so just think about this. If you can use your tyres to allow you to have a really stiff bike that doesn't vibrate, then you will use less energy or waste less energy with the vibration. That's more energy available to you to put into the pedals to go forward fast. So that's the first part over the theory, if you like, explaining why on real tarmac, not in the laboratory where it's perfectly smooth, on a real tarmac with little lumps and bumps, tyres that can mould around the lumps and bumps rather than go up over them can have a lower rolling resistance and can then help you to go faster for less energy. There are also advantages in puncture protection, in reducing vibration and making you less tired, and in keeping more rubber in contact with the road. And that's why all the research is saying that actually for road cyclists on tarmac, the sweet spot of 28 is best, going up to 30 or 32. It's not a great loss, and it could be worth thinking about, eventually, as a club rider in Salisbury, do I want to go for these bigger tyre sizes to get the maximum benefit and maximum safety and enjoyment from my sport? The thing is, you may have a bike frame and some wheels which are designed for smaller tyres. So if you want to go for slightly bigger tyres, you need to think a bit about, do they match? The obvious first thing to think about is the bike frame. Simply, can these bigger, wider tyres fit into the gap between the chainstays and the seat stays on my bike? The answer may be yes or no, and simply, if it works, great. If not, you might have to hold off the change until you plan to buy a new bike frame, whatever that is. But at least when you buy a new bike frame, you need to think about, well, do I want to buy a bike frame that will take these bigger tyres because of all their advantages? The less obvious thing to think about is the match of the tyre to the wheel, and especially the width of the tyre to the width of the wheel. Let's go back to sharing screen again. For any wheel, you've got to think about the inner width of the wheel. That's the gap between the two sorts of horns that hold the tyre in place. And for a fairly traditional wheel of a few years back, that gap might be about 15 millimeters wide, designed for a tyre of 23 millimeters, and that was fine. But if all of a sudden your tyre gets a lot wider, then ideally that gap also gets wider to get a wider base for the wider tyre. What you don't want is to have a very narrow base between the horns, the great big bulbous tyre, especially if you want to run at low pressures. I'm not saying you can't put a 28mm tyre onto a wheel with the inner width of, say, 17 or 19. It will work perfectly, but it would be better to have a slightly wider wheel, especially if you want to run at very low pressures. And if you want to run a wider tyre at low pressures, then ideally 21 or 22.5 are the standard recommendations for a wheel for tyres of 28, 30, 32. So that's the inner width. But then, mainly for aerodynamic tyres, you've got to think about the outer width of the tyre. Of the wheel, sorry. This is a aero profile of a few years back. The inner width is 21, perfect for wide tyres. The outer width is 28. The problem is that there's a rule of thumb for aerodynamic tyres and wheels called the 105 rule or the 5% rule, saying that to get a good aero profile, a smooth flow, you want the wheel to be at least 5% wider than the tyre, ideally a bit more. And if you have a massively wide tyre on a narrow wheel, you can have problems. This is perfect. You can see how the tyre is narrower than the wheel, with nice smooth flow over that transition between the tyre and the wheel. But if you try and squeeze a much bigger tyre onto the same wheel, you can see how the flow is changed, with the risk of loss of laminar flow and instability and eddies, which is not what you want. I'm not saying that you'll get no aero effect if you put a bigger tyre onto a narrower wheel, but the chances are you will get less benefit. The optimum is to have a tyre which is 5% narrower than the wheel, or perhaps even more. I use Hunter Aero wide wheels. They're 34 millimeters wide, and they are optimized for 28. So you've got this, 15% difference between tyre size and wheel size to get best aero flow. Okay, I use slightly bigger tyres, but I know there'll be some benefit as well. So that's all I wanted to say. I hope it's helpful, just to explain the new thinking, the new research around tyre size for bikes. How the older years of small tyres and massively high pressure are fading away, and all the manufacturers are saying the same sorts of things. The advantages to be had in moving towards bigger tyres, allowing lower pressures. because those work best on the real roads and tarmac that we get around Salisbury and in Wiltshire. I hope that's been interesting. Please do come back to me with any questions, either message me on Facebook or ask me when you see me out on the club rides around in Salisbury. Thank you.